Hello, welcome. We're back. We're working once more with CSFML, the C programming language binding for the simple and fast multimedia library. We're going to build once again on last time's work. First up, change the title to represent what we're going to do. I hinted at working on jumping, but I would want collisions working for that. I would need collisions working for that, and that's one of the things we're going to go over here. That's kind of the main thing. And we're going to set up some other things that are required for that, namely platforms. Select the platform texture first. Set int rect platform falls. And we're going to be using this. This is another thing I borrowed from Crouch Chaos, and it is 32 by 32. So we're going to want 0, 0, 32, 32 for the rectangle for the texture. And then we're going to actually create the texture. SF texture pointer platform texture equals SF texture. This will create from file, and it's called platform.png. And we need to specify how much of it to use, in this case all of it. So we're going to use that platform, use this, but the address of it because it wants a pointer there. So platform txrect. And then we're just going to set the texture repeating to true, so that if we create something that goes beyond the limits of the texture, it will just repeat the texture, which we are going to do because it's an easy way to create something that has more of the same texture. So repeated platform texture true. Now we're going to set up the platforms. Range necessary platform data. The number of platforms. This is an important thing because we are going to need to know how many there are to efficiently and accurately loop over them. So we're going to create a float rect of a float rect array of the platform bounds. That is the platform bounds are the boundaries, the sort of the bounding box that goes around, that describes the area that a given platform is in. And you just do that by specifying type, the name of the array, then left bracket, size of the array, right bracket. This is something that I messed up because the last element of the array is not going to be 3, it's going to be 2. And I was putting 2 there, but you want to put 3 if you have 3 elements. You just got to remember that they go 0, 1, 2. They start at 0. Arrays in C always start at 0. And we're going to set up some booleans for collision. Collision from the left and collision from the right. And the home platform. That is the one that the character is supposed to be on. That's going to be 0, as in the first platform. We're now going to set up those platforms. Create and set up platform sprites. So sprites pointer. And there's going to be a fair amount of this, but a lot of it's going to be similar. So there's going to be some copying and pasting. So sprite plat1 sprite equals SF sprite underscore create function. And then we set the sprite, SF sprite underscore set texture plat1 sprite to the platform texture, and then true to reset it, because why not? So I'm going to create an int rect to define how much of the texture to use. In this case, we're going to use all of it and then some, and that will make it repeat. SF int rect plat1 texture section equals, we're going to do 0, 0, 256, 32. So it is going to start at this corner of the texture, the upper left corner. It's going to only go down 32, so it's not going to be any deeper than the texture normally is. And it's 256, which is, I believe, 8 copies of the texture going to the right, or camera to the right here. Now we're going to use that texture. I'm going to set the set texture rect plat1 sprite plat1 texture section, and then we're going to create a vector for the position of it. SF vector 2f plat1 position equals, and this is where the platform is in terms of the upper left corner of the window being 0, 0, and x value is increasing as you go to the right, y value is increasing as you go down. So 0 x coordinate, so it's going to be aligned with the left side of the window, and a y coordinate of 192. So it's going to be down this way a bit. Now we're going to use that vector SF sprite score set position plat1 sprite plat1 position. And then we're going to get the bounds, and we're going to put it in this array we created up here. Platform bounds sub 0 is SF sprite underscore get global bounds of plat1 sprite. That is defined over here, right at the end of the sprite module, the sprite header. You have local bounds and global bounds. Local bounds is basically a way to get the bounding box of the sprite without any transforms. So skewing it or scaling it or rotating it, like ignoring that, what is the bounding box of the sprite? Global bounds is similar, but it gets where it's at in relation to the entire coordinate system. So basically the window. Now you can transform the coordinate system too. That will alter where everything effectively is. But that gets where it is in terms of the global coordinates. And then we're going to basically copy and paste all of this and change the names from 1 to 2. Right, two sprites. We're going to change the width here from 256 to 160. We're going to change the location from 0, 192 to 224, 160. And then we're going to store the bounds at location 1 in the array. Location of that. Alright. And then we're going to paste one more time, but this time we don't need the texture rect section. So we're going to delete that. Because it's just going to be one copy of the texture. Just one square of it. So plat 3 sprites. Plat 3 sprite. Plat 3 position. Plat 3 sprite. Plat 3 position. Platform bounds sub 2. Plat 3 sprites. Now, I'm going to go ahead and I altered the background color to make it more of a slate gray because I like that. I'm also going to change the math on this. This was the wrong number, that's why it was not stopping the player in the last video. And I'm also going to move player width over to this side of it. Plus player 1.width 480. And then we're going to put in the lines for all of the sprite drawing that we're doing. New window, draw sprite, main window, plat 1 sprite, null, plat 2 sprite, plat 3 sprite. Now, if I compile and run this, assuming I didn't typo anything, it will show those platforms that we just created. I did typo some things. Plat 1 position, I didn't create plat 2 position. Redefinition of plat 1 text, yeah. I forgot to alter a few things. There's plat 1. I can see right there, that should be 2. That should be a 2. Yeah, I was thinking about storing these in a struct, but I had some issues storing sprites in a struct earlier, and I just kind of didn't get to trying it. But it should be good now. Yeah, it doesn't like some of the pointers. Oh yes, that was something that I figured out. For defining textures, it wants an int rect, not a float rect. So let's recompile, and no complaints about it. Now, 4. It didn't draw the first. What do you call it? Oh, that's interesting. Okay, yeah. Since the platforms are drawing after the player. I'm walking behind them now. Let's draw them before the player. I don't know why number 3 is not showing up right. Figured it out. It's overlapping something else. I put in the wrong number. This is something you can get with specifying locations of things by hand numbering them and not creating in like a visual editor of an engine. Yep, there we go. That square off to the left, that was the 3rd platform. So the player, we're going to add one thing to the player. That is bounds. SF float rect bounds. We're going to define it. We're going to set the player position. Second page of code. This is 3 pages of code here. With this, that's with this small font that like what you see on the screen. SF sprite set position, which is you know, good to do ahead of time. Player sprite player 1 dot position, and then we're going to use that. Oh yeah, increase this player speed to 350. Although it looked kind of zippy there. I think the computer is doing weird things. And then player 1 dot bounds equals SF sprite underscore get global bounds of player sprite. Yeah, we can. Whoa. So this is all good. This is all good. Now we're going to add a bunch of stuff to the movement. First off, we're going to use these collision things. Going to move this up out of here. Actually, move this down out of here for right now. And we're going to do the opposite of what this says. Is less than, if it's less than or equal to 0, then player 1 dot position dot x equals 0. So fix it if it goes past somehow, and set moving left, so set left collision equals true. And then the same here. If it's greater than or equal to 480, then player 1 dot position dot x equals 480 minus player 1 dot width, and right collision equals true. And then we're going to set these to run if there is not a collision on that side. If not left collision, then do this. And you don't need, if you only have one line after your if line, then you don't need to use the brackets. And you can't actually put it on the same line. If it's short, I would recommend putting it on the same line. If it's longer, but it's one line, then you can put it on the next line. And if in good things like this, it will tab it over for you. Like I hit enter, and it automatically tabs it over. So, if not right collision, if I can type, All right. And we can compile and run that, and it will just act the same way, but it will do it differently. Except it will be a little touchy with turning around, I believe. No? Okay. And I could walk all the way to the right edge of the screen, but I think you can believe, well, I'm there already. There we go. Now we're going to modify the movement further. Going to add checking for the we're going to add collision checking. But first, going to set the opposing direction's collision to false, because, well, I'll show you. I'll show you when we get there. For loop int I equals 0, and you're going to need the int, the number, the variable, and an equals 0. I figured out the hard way that you're going to need all of those, or at least you're going to need the variable and equals 0 and define it before the loop. Otherwise, things are not going to work. And run as long as I is less than number of platforms, and on each loop add 1 to I. So if SF float rect intersects is the function that is in rect.h, which defines int and float rects and also contains and intersects, short little module, and takes 2 pointers and an optional third pointer for a rectangle describing the intersection, and returns a true or false, a boolean. So intersects ampersand player 1.bounds for the bounding box of the player, ampersand platform bounds sub I. Now you may think, if you know a bit about how arrays in C and related languages work, that using an ampersand and the array specifier here may do something weird. But it actually works just fine. This is how you want to do this. Although you could also do it like this. Just platform bounds plus I, no ampersand or star, and just adding to it, because it works out the exact same way, because arrays are just adding an integer index to an address. But we're going to specify it like this, as a slightly more normal array specifier, and specify null for the intersecting rectangle. And if that's true, then, okay, so we're going to loop over the platforms. We're going to check each platform, if each platform intersects with player. So here's the platform. It tells, you know what, let's call this index. Plat index. Make it more descriptive. Plat index. Plat index. And plat index. Now then, if the platform bounds as that belong to plat index here, whichever one we're currently on in the loop, intersect with the player's bounding box, then we're going to stop the collision. Except it's a little more complicated than that again, and I'll show you why. If plat index is not equal to home platform, then left collision holds true, and reset the player's position so they don't bump up against it over and over, which it's another thing I can show you. Player1 dot position dot x equals platform bounds sub plat index dot left, so the left side of the bounds, because they are defined as left, top, width, and height, plus platform bounds subplat index dot width. Now, that is all set now for moving left. Moving right is going to be the same deal, just change to it. But first I'm going to show you what happens if you don't have this bit. Might be hard to see, but oh, I guess it's just not going to work. Okay, yeah. It's doing, now that there's been a left collision, which it did detect apparently, it's not letting it move left at all. It's not resetting it. I don't know why it wasn't stopping the player, but it was not stopping the player. But yes, that's what happens if you don't have checking for the home platform. But it's already doing that, so makes no odds. So now down here in this section, going to set left collision to false. Going to do the same loop, but changing a few things. Plat index, plat bounds, home platform. We're going to set right collision to true. Platform position.x equals platform bounds sub I dot platform bounds supply index dot left minus player1 dot width player1 dot width that should be good. Alright, just a moment while I figure out why it's not working. The problem, of course, was something that I did not get to yet. And I just had this problem and fixed it earlier, and I forgot. So down here, set the player's position and get their bounding box. Player1.bounds. We need to update the bounds. So have data on a regular basis. So sprite underscore get global bounds player sprite. So now, when the player bounds are checked here and here, and checked to the intersect with a given platform that is specified by the index here, it will return correct collisions. Dink. And dink. Yeah. Yes, you see I phase into it a bit and I press it again and it fixes it. But yes, that is in fact it for this time. That was collision detection. It's made a little bit easier by SFML, by this intersecting rect function. Next time will in fact be vertical movement. All floaty and bouncy. Well, not bouncy, but I'll see you then. Bye.